Hello, my name is Elizabeth Berhaney, and today I will be presenting on the autoimmune disease multiple sclerosis, most commonly referred to as MS. So the name for MS is encephalomyelitis disseminata, encephalo coming from the Greek word for brain and itis coming from the Greek word for inflammation. And so it is an inflammation of the brain. The characteristic sign is scars on the brain and the spinal cord. And this is what gives the name multiple sclerosis. Sclerosis comes from scar. And I found that pretty interesting. And so it is when the immune cells attack nerve fibers and myelin sheaths of the central nervous system, which causes inflammation. And this leads to the destruction of myelin sheaths. And for a refresher, myelin sheaths are that fatty tissue that surround and insulate the long fibers of nerve cells. And so you can see in this picture right here, those blue things, those are myelin sheaths. And obviously the central nervous system is hugely important to the functioning of any human. And so any disruption in these impulses will have large effects potentially, and they affect any type of movement that you can do. And so these lesions, I have a picture. These lesions you can see in an MRI scan. And so that's like the final diagnosis for MS is these lesions. And you can see they're like these little ovals, and here you can see in the spinal cord. And so, yeah, it's really interesting. You can have symptoms, but you can't be diagnosed for sure until you see these on an MRI scan. And so there's 4 types of MS. Clinically isolated is the first episode that you might have. And so it's an episode where you experience the neurological symptoms of MS for more than 24 hours. And experiencing this episode does not necessarily mean that you have MS. It can just come and then go, and for the rest of your life, you never experience anything else. But after this episode, you do need an MRI scan. And if they find any lesions, then it does mean that you have one of these 3. Primary progressive MS is a gradual progression of the symptoms and loss of function. And it might level out so you don't have any worsening symptoms, but they never go away. They never get better. And you might have little episodes during it. And then secondary progressive is a lot more vicious. And so it begins with a huge episode where you experience a lot of different symptoms. And we will discuss those in the slide next. But it's like this really big episode, and then it goes away, and then begins this it's not quite as gradual as PPMS. And so it's just this more progressive type of symptoms and loss of function. And there might be other episodes, and these episodes are bigger than primary progressive. And so it's just a more intense type of MS. But thankfully, most people have relapsing remitting MS. About 85% of patients have RRMS. And these are episodes that in the interlude are complete regressions and remissions of symptoms. And so you can live your life just having these episodes. So it can be, patients can have anywhere from it's kind of bothersome to completely debilitating symptoms. And they come in stages. And yes, so most people have RRMS. And symptoms, so John Martin Charcot is the first doctor and scientist to describe MS as a distinct disease in the 1800s. And he came up with what is now called Charcot's triad, which is 3 very characteristic symptoms of MS. And so they are diplopia, ataxia, and dysarthria. And diplopia is seeing double of everything, of objects. You have double vision. Ataxia is impaired balance and coordination of your body. So just trying to walk around or trying to like pick up a mug or do anything that requires any type of coordination is impaired. And that's a way that you can begin to suspect that someone might have MS. And then dysarthria, which is slurred words. And so there's a weakening of your vocal, the muscles of your vocal box, and this results in slurred words. And there's also many other symptoms like loss of vision in one eye, loss of power in a limb, it just goes limp, tremors. There's, as you can imagine, the central nervous system affects your entire body. So really, you could have any symptoms that affect muscles of your body, any type of function with movement. These can all be affected by MS, but really these three in the triad are really distinctive. And if you have all three, then you should definitely get an MRI scan. And so we have about 2.8 million people who live with MS globally as of 2020. 1 million are Americans, which is a pretty large percentage of the global amount. And then there's about 19,000 deaths associated with MS in 2016. And it's kind of a hard stat to find because MS is not considered lethal. It's just debilitating. There's symptoms that come and go usually. And so, yeah, so there are so few compared to 2.8 million. There's so few deaths because in reality, you don't die. You don't have like a, when you get diagnosed with MS, it's not like you have a few years left to live. But people on average live about 5 to 10 years less long than the average healthy human. So it's not like a death sentence or anything, but if you have severe MS, then you might live slightly less long. So the global prevalence of MS, I found really interesting because so in America, Canada, and the Netherlands and that area, there's about over 200 per 100,000 people. And then in Australia and Europe is second most prevalent, and then Russia. But as you can see, South America, Africa, and Asia have only 0 to 25, which I found really strange, but it's actually due to the fact that MS is kind of hard to diagnose. You need an MRI machine and you need doctors who are able to work that and to diagnose patients with that. And so, and it also takes like recognizing the symptoms and being able to afford an MRI scan. And so in reality, there's probably a lot more people living with MS, but due to lower resources and less resources, they are not able to be prescribed. And so that's a really big project for the MS Society, and the World Health Organization is getting accurate numbers and getting resources out to people. So on a map, it might seem like there's less, but in reality, people are just suffering and no one knows. And where does MS come from? So there is no definitive answer as to what causes MS, like what is the underlying reason. And so genetics plays a part. Family studies have found significant correlation between family members who have MS and how their family members are at an increased risk. But we know that it's not entirely genetic because homozygous twins, one can have MS and the other is healthy. And then what I ran into a lot in my research was this locus, HLA DRB1 1501, accounts for a 30% overall increased risk for MS if you possess this in your genes. So there's a lot of research going into like just looking at this locus and why it comes about and how it affects MS. And then also really interesting is environmental factors. So if you, as a child, lived in a very low altitude area and then moved to a very high altitude home, you are at an increased risk of MS, as well as high altitudes in general give increased risk of MS. And then spring births versus autumn births, strangely enough, spring births are more prone to MS. And they think it might be due to vitamin D deficiency. And so if you have vitamin D deficiency, again, it's not certain, but there's research that favors that deficiency in vitamin D causes increased risk of MS. And so that might be the reason behind some of these environmental factors. And then also the Epstein-Barr virus, if you contract that, you're at a much increased risk for MS. And so the role of immune cells in MS, all immune cells are really involved in the disease, whether to help it or contributing to it. And so one thing that's really interesting is that the blood-brain barrier is what normally protects the brain and the spinal cord from antigens in the blood and also from any immune cells. So there's a few surveillance immune cells that are allowed to kind of patrol the central nervous system, but it's really off limits to all immune cells. And so in order to cross the blood-brain barrier, T cells and B cells and natural killer cells had to find a way to get past this and get to those nerve cells. And so T cells are the central player in MS. CD4 positive T cells, which secrete IFN gamma, are like the biggest area of research in terms of cell because IFN gamma is the main mediator of inflammation, as well as T helper 17 cells, which secrete IL-17, 6, and 23, which are also pro-inflammatory. So basically any cytokine or any molecules that activate inflammation are going to play a role in MS because inflammation is really what causes that damage to the central, to the myelin sheaths. And chemokines also have been shown to be important for getting those adaptive immune systems across immune cells across the blood-brain barrier. And it's not entirely known how they do that, but they do play a role. And then B cells also have become more known to be important in MS. Before it was just really T cells they were focusing on, but B cells play an important role in that they present antigen, they're antigen presenting cells, and they are able to activate T cells. So whether that's before or once they're already in the CNS, they're able to activate these pathogenic T cells that then attack the nerve fibers. And they also produce antibodies. And these antibodies attack, like these bad B cells produce antibodies that attack. And so both of these roles play an important part. And the natural killer cells, interestingly, I thought an increase in natural killer cells would be an increase in MS, but actually decreased natural killer cells, I think because they can, they serve to kill off like mutant pathogenic B and T cells. And so if there's a decrease in NK cells, then there's an increased risk of MS. And so the infection process, so you have your factors, your genetic and environmental factors, and then the B and T cells are targeted in the periphery to invade the central nervous system. And so already while they're being formed, these pathogenic B cells escape from T cell mediated control in the peripheral centers. So these aren't mature B cells that are like going around the blood and stuff. They're still, as they're being formed, they get out from T cell control and they kind of like go rogue basically. And then these naive pathogenic B cells interact with T cells in the germinal center and they activate these T cells. And so now we have B and T cells that are able to, they go to the choroid plexus, which is one of two of like the weak points of the blood-brain barrier. And that's where there's like, you find pools of lymphocytes. And so they get there, and it's, again, it's not entirely known. There's a lot that's not known about MS, but once they're there, they're able to enter somehow, and then, and then attack. And they just, they basically see the nerve fibers and the myelin sheaths as antigen, and they just attack it. And that's what causes the symptoms of MS. And then also something I found interesting was that I had been watching a lot of commercials about MS, and I never knew what it was. It was just in one ear, out the other. But you might have seen these commercials for Ocrevus, and now you know that MS is multiple sclerosis, and you know more about it. So thank you. And those are my resources. And yeah, I hope you enjoyed.